Alright, so problem 2b is a little weird, because if you look at it, we know that it's not arithmetic, because we can take 1/3 minus 1, and we get negative 2/3, and we get 1/6 minus 1/3 is not negative 2/3. We don't have a common difference each time, so it's not arithmetic. It's not geometric either, though, because if you think about 1 times 1/3 gives you 1/3, but 1/3 times 1/3 gives you 1/9, which is not our next term. So it's not arithmetic, and it's not geometric either. So that's kind of weird. But I do notice a pattern between these numbers. If you look at all those fractions, so kind of ignoring that first term, but look at all those fractions, you can see that the denominator in each case is just going up by 3 each time. So like 3 plus 3 is 6, 6 plus 3 is 9, 9 plus 3 is 12. But the problem is that pattern doesn't fit with our first term, because go the other way, 9 minus 3 is 6, 6 minus 3 is 3, 3 minus 3 is 0, and we would get 1 over 0, which is undefined, which sucks. So I'm going to kind of ignore, not ignore, but like, I'm just going to come back to that 1, and I'm going to focus on everything else for now. Because if I do that, I can actually write myself a series to represent that. So notice in each case the numerator is 1, but the denominator is a power of 3. And if we go ahead and list our term numbers, let's call that term 1, 2, 3, 4, n. If we do that, then you can see that for our first term we have 3 times 1 is 3. For our second term, we have 3 times 2 is 6. For our third term, we have 3 times 3 is 9. For our fourth term, we have 3 times 4 is 12. So it is actually following this pattern, 1 over 3 to the n. The problem is it just doesn't fit with that first 1. So I'm going to cheat, and I'm going to be sneaky, and I'm going to write this as 1 plus the sum from n equals 1 up to something. I'm not sure what that n is yet, but of 1 over 3 times n. So let's figure out how far I need to go. So 1 over 39 equals 1 over 3n. So 3n equals 39. And so n equals 39 divided by 3, which is 13. So if we're clever, we can actually write our series like that. 1 plus the series from n equals 1 up to 13 of the general term 1 over 3 times n. Doesn't look like we normally have it, but there you go nonetheless. Now, we can actually go through and add all these up, but oh man, that would suck, and I really don't want to do that by hand. So I'm going to say, why don't you go ahead and do this one on your calculator. So try to remember how you do that. Remember that once you turn your calculator on, you're going to want to hit second and then hit the stat button to give you the list options. Go over 2 times until your calculator says math, and then it should be option 5, gives you the option for a sum. And you want to select that, and then it'll print sum on your screen like that. And then we actually want to go back in, so hit second again, stat again, and this time arrow over 1 till the heading says ops, O-P-S, and then again we want to choose option 5, which is sequence. We want to get the sum of this sequence. Then we need to tell it what the sequence is. Well, the sequence is 1 divided by 3x, and then we need to do a comma, which is on your calculator right here above the 7. And then we need to tell it that the variable we're dealing with is x, and then do a comma, and then put our first term 1 and our last term 13. Do that, and your calculator should tell you And just kidding, don't actually do that yet because I just noticed you need parentheses around that 3x. Otherwise, your calculator will interpret it as 1/3 times x, which is x over 3, totally different than 1 over 3x. So make sure you put parentheses around that. Do that, and you should get the sum 1.06 with a lot of other ugly decimals, but we'll just stop it there because the next two are 0, 0. So 1.06, but then don't forget, you still need to add in that 1. So our final answer for the sum should be about 2.06. And now we're off. There is technically a fraction that we could represent for that decimal, but it's so ugly, it's so ridiculous that our calculator won't even tell us what it is. So just give us a decimal for this one. Totally good.